This video is for section 4-2, multiplying polynomials. The distributive property and the exponent laws enable you to rewrite the product of a monomial and any polynomial. Here's an example. In red ink is a monomial. It's being multiplied to the polynomial that is in black ink. And this is done with the distributive property. The note page has the work started, but on these blank spots, we need to write down the factor that's missing. What goes on this first blank spot? What gets multiplied to the 4x squared? It's the negative 5x squared. What goes on this blank spot? What gets multiplied to the 2x? It's the negative 5x squared. And on the last blank spot, negative 5x squared. This is the distributive property. Then there's a blank spot for the final answer. Negative 5 times 4 is negative 20, and x squared times x squared, using the rule about adding exponents, is x to the 4th. Negative 5 times 2 is negative 10, and x squared times x to the 1st is x to the 3rd. Negative 5 times negative 3 is positive 15, and x squared times no more x's is x squared. So the final answer is a trinomial, and to create the terms, we're using the distributive property. Here's another example. Multiply the binomial in red ink times the trinomial in black ink. I've left some blank spots. What's missing? On the first blank, what's missing is the 3x. The 3x gets multiplied to this entire trinomial. On the second blank, what is missing? It's the 2. The 2 has to be multiplied to this entire trinomial. After we've started the problem, let's do the next work step. Some more distributive property. 3x times 4x squared is 12x cubed. 3x times 2x is 6x squared. 3x times negative 3 is negative 9x. 2 times 4x is positive 8x squared. 2 times 2x is positive 4x. 2 times negative 3 is negative 6. The final step is the combining like terms. Begin with the 12x cubed. It has the highest degree. Then look for any x squared terms and combine them together. Then look for x terms and combine those together. And finally, the constant term. The technique for multiplying polynomials is very straightforward. It is to use the distributive property. But what can make it challenging is you have to use the correct exponent laws, you have to get positive and negative signs correct, and you have to be able to combine terms correctly. When multiplying two binomials, try to multiply them by sight. What I mean by that is directly get the answer without writing any work steps. For example, 7y minus 3 is a binomial times 2y plus 5 is a binomial. From the example we just worked, we know we need to take each term from here and multiply to each term from there. Let's do that by sight. 7y times 2y is 14y squared. 7y times 5 is 35y. Remember that. Negative 3 times 2y is negative 6y. Then, in your mind, combine the 35y and the minus 6y. That makes positive 29y. Finally, multiply the negative 3 to the positive 5. That makes negative 15. Being able to directly get the answer will save you a lot of time instead of having to write all the work steps down like this. 7y times 2y is 14y squared. 7y times 5 is positive 35y. Negative 3 times 2y is negative 6y. And negative 3 times 5 is negative 15. Then combine those together. It is much faster to go directly to the answer as long as you can do that intermediate work step in your head. Besides being able to multiply binomials by sight, we also want to work towards learning some special patterns. The first pattern will help us quickly square a binomial. Here are the two patterns. To square a plus b, follow this pattern. To square a minus b, follow this pattern. If we try to put into words what the pattern is showing, we can see that we are asked to square this number. On the end, we're asked to square this number. And in the middle, we're asked to take twice the product of the two numbers. Let's try a couple examples. First, we have to recognize what we have, squaring a binomial. Then we can apply the pattern. Square the first number. 2m times 2m is 4m squared. Square the last number. 5 squared is positive 25. In the middle, we want to take twice the product of the two terms. 2m times 5 is 10m, and twice 10m is positive 20m. I got this trinomial answer by following this pattern. Let's try another example. We have to recognize the pattern. We have a binomial in parentheses with two terms, and it's being squared. So it's this pattern that we want to follow. The a squared means to square that first thing. That makes 49k squared. On the end, the b squared means to square this last number. That makes positive 16. In the middle, the negative 2 times a times b means to take twice the product of these two numbers. 7k times negative 4 is negative 28k. Twice that is negative 56k. Here's another special pattern called the product, because you're multiplying, of a sum and a difference. To quickly get the answer, we square the first term and square the last term. Let's try that pattern. First, you recognize it when you see it. This binomial is the same as this binomial, except this is a sum and this is a difference. Let's apply the pattern rule. The a squared means to multiply this number times this number. So 6t squared times 6t squared is 36t to the fourth. Minus. The b squared means to multiply this number times this number. 11 times 11 is 121. Next example. Does it fit that pattern? Are the binomials identical, except one of them is a sum and one of them is a difference? And the answer is yes. So let's use the pattern. 1/2 x times 1/2 x is 1/4 x squared. Minus, and then 3 times 3 is 9. Let's summarize the lesson. We reviewed using the distributive property to multiply a monomial times a polynomial and a binomial times a polynomial. We also looked at two special patterns that get the answer faster. One of the patterns will help you to quickly square a binomial, such as this. You square the first term and square the last term and double the product of the two terms. The other special pattern helps you to multiply a sum times a difference, like this. You multiply the x times the x, minus, and multiply the 5 times the 5. If at any point you do not remember the special pattern, or you don't recognize that there is a special pattern, you can use the distributive property. For example, let's say we had the problem x take away 4 squared. And we don't recognize or don't know how to use the special pattern. X minus 4 squared means x minus 4 times x minus 4. Now we can use the distributive property. X times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. And negative 4 times negative 4 is positive 16. The x terms can be combined. So you can still get the final answer even without knowing the special patterns. It just takes more time.